So this is question 30 from DSE 2022 MA Economics entrance paper. So the question says this: there are two players A and B. They are playing the following game. In each round, one of the players draws a number randomly from an urn containing numbers. The numbers are 0, 1, 2, 3, 4, and so on until 9. Suppose that player A is drawing at round T. So A starts game at round T. However, if she draws a positive even number, then the continues to draw at around t plus 1. However, if A draws an odd number at t, then player B gets to draw it around t plus 1. If 0 is drawn, then the game ends. Rules are same for both the players. Suppose that A starts the game and the probability that game ends with at most one player change. We have to find probability game ends with at most one player change. Okay, so let's start solving this. So we have to make two cases in this problem. Remember that we are allowed at most one player change, at most one switch. Okay, so basically we make cases, two cases. The first case would be uh, eventually that there is no switch, that is zero switch. Now, when this is possible, when A, since A is beginning the game, then A eventually draws zero. And in second case, we have one switch in which A goes to B and B eventually draws zero. Now, how will this be possible? When A eventually draws odd number, then B eventually draws zero. Okay, so let's try and let's begin to solve case wise. So first we have numbers 0 to 9, n equals, we have 10 numbers. Okay, case 1, A eventually draws 0. Okay, so the game star says that if A draws an even number, then A will continue the game and so on, but A eventually draws 0. So probability of even, we have 2, 4, 6 and 8, that is 4 by 10, that is 2 by 5. Now probability that A eventually draws 0. Now this would be about uh, understanding that A can draw 0 in the first attempt itself. So we have probability of drawing 0, that would be 1 by 10. So A can draw 0 in first attempt. Then let us suppose that A can draw 0 in second attempt, but before that 0, A draws an even number since A is playing the game. Then maybe A can draw 0 in third attempt and so on and so on. This would be solving a geometric progression. So this comes out to be, we take 1 by 10 common, we get 1 by 1 plus 2 by 5 plus 2 by 5 whole square and so on. This gets 1 by 10. We apply A upon 1 minus R, that comes out to be This comes out to be 5 minus 2, 3, 1 by 6. Okay, so this is a case 1 probability. So let's move back to case 2. Okay, so we have drawn we have calculated case 1, that is no switch. A eventually draws 0. This comes out to be 1 by 6. Now case 2, we have one switch. When A eventually draws an odd number, then B gets into the game, then B eventually draws 0 and the game ends. Okay, so let's now try to solve for case 2. Let's add a page. Okay, case 2, A eventually draws odd, then B eventually draws 0. So probability would come out to be, let us say A in the first attempt itself draws an odd number. Probability of odd number is coming out to be, probability of odd would be 1, 3, 5, 7, and 9. 5 by 10, that is 1 by 2. Okay, so let us say that we have probability of odd. A can draw odd number in the first attempt itself. That comes out to be 1 by 2. Or it can happen A draws odd number in second attempt. So before that he draws even number. That would be 2 by 5. Now A draws odd in the third attempt, and so on. Now again solving in the likewise manner, we get this to be a geometric progression again, and we solve it in the same manner. We get A upon minus R. We get this to be 1 by 2 whole into 5 upon 3. This is 5 by 6. Okay, but this is the probability that A eventually draws an odd number. Now the game has switched to B. So this is a bit of a complex question, but we have to understand it. In the second case is a bit tricky. So now A eventually draws an odd number. Now game comes to B. Now B, the rules are same. If B continues to draw an even number, the game would continue with B only. But if B eventually draws a 0, the game ends. So now we find the probability B eventually draws 0. Now this game is symmetric, rules are same for both the players, so we have no need to calculate this separately. We have already calculated in case 1 that the probability of a player eventually drawing 0 is 1 by 6. So this would be again 1 by 6. This would be again 1 by 6. Okay, so the total probability would be multiplying both these events. A switches to B by eventually drawing an odd number, and B eventually draws a 0, and the game ends. So this would be 5 by 6 into 1 by 6. This works out to be 5 by 36. So now we add both these case probabilities, and the final answer, probability at most one switch, comes out to be 1 by 6 plus 5 by 36. Taking the LCM, we get 11 by 36. Let's check which option is that. One second. So this is option number C, 11 by 36. Thank you.